So, oxidation reduction reactions, this is our last unit for the year. I know you're excited about that. We are going to be talking about these types of reactions, which are when electrons are transferred. Okay, so in this case, electrons are either going to be transferred by gaining or losing. We often call them redox as for short, and it's the RE comes from the reduction, the ox comes from the oxidation. So you will probably from here on out hear me call them redox because it's quicker and easier to say. They're just another type of chemical reaction in addition to the one we studied earlier in the year of synthesis, decomposition, etc. You'll actually find that many of those that we studied are actually in fact redox reactions because electrons are being transferred. So in order to decide if something is a redox, we have to see something called its oxidation state or oxidation number to see if it changes or not. Okay, so what an oxidation number or state is, it is a positive or negative number that's assigned according to an arbitrary set of rules. It is not the same thing as charges. So like in the beginning, the semester when we did ionic charges, it is not the same. Now, in some cases, the ionic charge will be the same as its oxidation number, especially for metals, but in other cases it's going to be different. Okay? Unlike the ionic charges, they actually don't have a physical meaning. It's a way for us to determine what's going on in terms of the electrons being transferred. Here are the arbitrary rules. Okay? And you do use these in order. In other words, if you have, say, fluorine and oxygen together in a compound, fluorine's rule of being a -1 would trump oxygen's rule of being a -2. Okay, so they are used in order. First rule is that the oxidation of should be oxidation number, of a free element is always 0. Okay, so if I have aluminum by itself, it's 0. If I have copper by itself, it's 0. Also, if I have one of the diatomics, like oxygen, nitrogen, the Brinkelhoffs, remember in their free state, they're diatomic, but they would have an oxidation state of 0. So that would stay the same. If you have a monoatomic ion, it's the same as its charge. Okay, so like group 1 and 2 metals, their oxidation number will be the same as their charge. So sodium, potassium, etc. would be +1. Magnesium and calcium, since they're in group 2, would be +2. So their oxidation number in that case is going to be the same as their charge, their ion charge that we're used to. If it's in a compound, fluorine's always a -1. Remember, if it's by itself, it's 0, but if it's in a compound, fluorine is the winner because it's so electronegative, it'll always be a -1. Oxygen is almost always a -2 unless it's in a peroxide. I would tell you if we have a peroxide, I would say that's a peroxide. Most likely we won't see one in here. But the only peroxide you might even see in here that you would know is a peroxide is hydrogen peroxide, which is H2O2, which is the stuff you get in the brown bottle that fizzes when you put it on a cut. So that would have that one would be -1. Otherwise, oxygen is going to be -2 when it's in a compound. Hydrogen is always going to be a +1 when it's covalent, and covalent means 2 nonmetals, right? Is anybody awake? Okay. If it's in a metal hydride, say like sodium hydride, then it would be a -1. Again, we're almost always going to see it in a covalent compound. And then this is the important part we need to remember. The sum of the oxidation states is 0 for compounds. But if it is a polyatomic ion, it would be the sum of that ion. Okay? And that actually tripped a bunch of the pre-AP kids up when they asked a question about what's the sum in a compound. If we're talking compound, it's going to be 0. The sum's got to be 0. So that's how we'll use that to figure out what some of the charges are. Okay, so we're going to do a couple of examples in class, and then you have the worksheet, and it's due Monday. And then that's all we're doing today because I want to make sure you understand it. If you finish the worksheet early, you can go ahead and turn it in by the end of class if you want. So let's do some practice problems. We have lithium. When lithium is all by itself, what is its oxidation? 0. Okay, so that would be 0 because it's by itself. If I have this calcium carbonate, okay, calcium carbonate is going to be, what we need to do here is we're going to figure out the things we know for sure and then come back and do the last one by itself and figure it out based on what we know. So calcium is a group 2 metal, And so its oxidation number is going to be the same of its charge, which is a what? +2. And technically, we can write it either way, 2 plus or 2 or +2. And then carbon, we're going to skip because we don't know what that is right now. But it did tell us about oxygen. And what did it say about oxygen? Always a -2, unless it's with the peroxide. And this clearly is not peroxide. So now we're going to figure out, can you tell that says 2? There. Okay, so now we're going to figure out what carbon is. And there's one of two ways that we can do this. Okay, I like to pull out the polyatomic ion by itself and figure it out from there. So this is the polyatomic ion, and that is carbonate, and it has a -2 charge. Okay, so I'm going to figure out what carbon is because I know how much oxygen I have. Okay, when you're assigning the oxidation states, you are assigning it for the individual elements, not your total. Okay, but to figure out what the other oxidation numbers are, you're going to figure out what's your total negative charge here. So if you know that oxygen's a -2 and you have 3 of them, what's the total negative charge of oxygen? So it's -6 down here. Okay, we need carbon to be whatever number that we would add up to a -2. So what plus a -6 would equal a -2? A +4. So that has to be +4. So our carbon is a +4. Okay. You can do that if it's left in the compound as well. It just is sometimes a little bit harder. Not so much when you just have one of your polyatomic, but if you have 2 polyatomic, it gets a little bit more difficult. So it's best to just pull out that polyatomic and do it individually. But you could have figured it out if you know this is +2 and this is -6. You could have figured out that that had to be a +4 to equal the overall charge of a 0. Okay, and for this it's pretty easy, but if I were to do, say, this compound, actually that needs to be a 3 and a 2, then it would make it a little bit harder. So then it'd be best to just pull out that phosphate. Okay, so at the bottom of this same page we're going to do these 4 extra because I feel like one example is not really enough before we try to do the worksheet. Your left side on the next page is some of these to practice. And of course you have the worksheet as well. So we're going to do potassium permanganate. Okay. Oops, sorry about that. So potassium is a group 1 metal. So that means its oxidation number is going to be the same as what its normal charge would be, which is a +1. Okay. We're going to find out manganese and we're going to find out oxygen. Okay. Oxygen, the rules tell us, is always a what? -2. So we've got to figure out what manganese is in this case. Okay. Manganese, so we know we have a +1. We have a total of a -8. Right? Because we have 4 of them. So to make this electrically neutral, what is manganese have to be? Huh? Well, right now I have +1 and a -8, so I have a total of a -7 right now, right? So what does manganese have to be to make it equal 0? +7. Have to be +7. Okay? Again, if you were going to do it by pulling out manganese, the polyatomic manganese is MnO4 with a -1. So same thing, this is a -8. That means this would have to be a +7 to equal the -1. So you can do it either way. You can do it the whole thing or you can do it as the polyatomic. If it's the whole thing and there's only one polyatomic, it's probably just as easy to keep it in the compound. But if there's multiple polyatomics, it makes it a little bit harder. Okay? And I chose these next 3 on purpose because they're sulfur and oxygen in all of them. But if you look, this one is sulfur trioxide because there's no charge. This is sulfite, SO3, 2-, and this is sulfate. Okay, so we're going to be figuring out what the charge of sulfur is in each one of them, and oxygen. But we know oxygen is always -2, so we're going to do -2 on all of those. Okay, so now for this first one, I am electrically neutral. Okay, so I have a total of a -6. So since I'm electrically neutral, meaning there's no charge, what does sulfur have to be? A +6. Okay, For the sulfite, which is SO3 minus, still a -6, but now I need to overall equal a -2. So what plus a -6 would equal a -2 plus 4? Okay. And then in the sulfate, now I have a -8 total. So what plus a -8 would equal a -2 plus 6? So in that case, sulfur had the same one as sulfur trioxide. Okay? So on your worksheet today, you're just going to figure out and assign an oxidation state for each one of the elements in a compound. Okay? There's one on there, I believe it was number 5, that is ICl3. No, it's number 4. So for number 4, where it says ICl3, use that chlorine as a -1 and then figure out what iodine should be. Use that chlorine as a -1. Okay? And then on number 10, zinc ZN3P2. Okay, zinc individually is going to be a +2, so that'll help you figure out what phosphorus is. Okay? But honestly, if it's an ionic compound, it's going to be their oxidation states are going to be the same as their charges were.